Mr. Zentner. This is Noah Pfister's math art project. I'm doing a drawing of a city using the vector ideas as well as perspective work. I'm going to show it now. I call it Vectorville. I'm very proud of the name. Go over a slow showing so that you can inspect everything more clearly. There you go. Now I'm going to go over one by one the different elements. First of all, the point, the sun. I thought it was a good starting point, pun intended, right here. Plus vector A, and it's negative, minus vector B. We can see right here the up of A and the down of B. They are identical vectors but negative. We have C, the vector plus or minus C. Right here, kind of like A and B, except that it works both ways, going either up into the sky or down into the ground. I like it a lot. For null vector n, it is the center of the clock over here, serving as an axis between, for the different hands of the clock. The z plus v is equal to s, the addition of vectors. For me, I have z over here, which is the ground vector up until the shadow, and then t, which is the vector until the end, all forms one big S vector, which is the separation between the ocean and the city. Then there is very similar, the x minus w is equal to d to make a new vector. I have over here, x minus w is equal to e of these lines. Kr is the vector r multiplied by scalar k. I have the first vector r over here, r. Then multiplied by scalar k, which is longer r. These two buildings, perspective work, you know how it is. Then here we have the dot product of the two vectors. I have right here the dot product of f and w, giving the resulting vector as well as the angle. Yep, absolutely tremendous. Parallel projection, we have the parallel projection of the sun onto the building, forming its reflection in the water. So the projection of the sun onto the building. This is my parallel projection. Then the orthogonal projection, a little bit trickier. We have the sun, perspective onto the building. We got the shadow over here. The line formed by the shadow, that is my orthogonal projection. Same thing, sun onto this is equal to this, projection sun onto A. Then we have unit vector u. That is my baseline for my scale of 1 across my drawing. There is here vector u. We have specified that its length is equal to 1, as it should be. Then over here, 2D normal vector. This one is very much just like parallel vector present all across my drawing. It is right here, correct, with the two arrows. There's an example. Sit down. That's the parallel of the sides of the building. It's kind of everywhere. I have a very parallel drawing. Then we have, oh, did I skip? Yeah, 2D normal vector right here. It is the 2D formed by the Q and B vectors, giving a nice 90-degree angle. So yeah, the Q is essentially the normal of the B poking out over here. Then we have a rotation, which is the rotation of the V vector for the clock, which rotates here to form the V with the little thing on it. So yeah, that is my rotation, which I think works well into the rotation of the clock. Oh yeah, there's also like the little angle here. And there's the transformation, which is the big building, which goes to the small building. We can see which is the original, which is not. They're identical, except that the size has been scaled. Yep, that's basically it. Thank you very much for watching. Before I go, yeah, I think that's it. What do you call jail for rainbows? Prism. Yep. Anyways, thank you.